It is now my pleasure to introduce to you today's presenter, Fred Romig. Take it away.
Thank you, sir, and welcome everybody to this good presentation that's forthcoming. So here's what we're going to talk about today. This time we're talking about ventilation systems. The second most unique feature of a chemical building is its ventilation system. It is upside down as compared to familiar systems designed to remove hot air buildup at ceilings and from attics. During a spill, flammable combustible liquids will flow down through the elevated floor to the bottom of a flat sump floor, spreading evenly all over the building. This provides the greatest surface area for evaporation, which will create the fume. Immediately after a spill, the liquid is exposed to the air. That's even before the liquid even hits the floor. Evaporates and becomes a fume or vapor. This fume is usually heavier than air and will drift down, adding to the total fume accumulation across that flat sump floor. The fumes will begin to rise upward past the elevated flooring. If the fume-air mixture reaches a particular percentage depending on the chemical, it is susceptible to ignition by flame or spark. If ignited, an explosion in the building will occur. Ventilation is a solution. NFPA 30 Flammable Combustible Liquids Code, paragraph A-4-6 says simply, quote, ventilation requirements include mechanical ventilation where dispensing operations are expected, unquote. We'll talk more about the different types of ventilation systems on the very next slide. There are three types of ventilation systems. There's gravity ventilation. A single opening in the lower wall of the building is fitted with a rain louver and a bird screen. Now, if it's a fire-rated building, they add a fusible link drop-down shutter. Now, this acts as a vent. The top of the rising fumes will be pulled out of the opening by gravity like a hole in a coffee cup, allowing the fume to drift down on the ground where it eventually dissipates into the atmosphere. If there was another vent, like the first one on the opposite wall, the wind outside the building can push fresh air in and or pull out the fumes outside. This is the least expensive and least dependable method. Then comes natural ventilation. Now this starts with the same single low-level vent just described, but the second vent is placed high up on the opposite wall near the ceiling. This expels hot air near the ceiling, but near the floor, under the upper vent wall, for more than a half of the building, the fumes remain. This is a cheap solution and does not do a good job of expelling heavier-than-air fumes. Now we'll talk mechanical ventilation. It starts again with a low-level vent becoming the air intake, and the second low-level vent on the opposite wall acts as an output, similar to the gravity ventilation solution we already talked about. Here, outside the second vent, has installed a vertical stack or duct up on the exterior wall. The fan, per NFPA 30 paragraph 18.5.5, shall provide 1 cubic foot per minute of exhaust air for each square foot of floor area, creating a negative pressure in the room. This comes to over 6 air changes per hour. The International Fire Code, paragraph 2704.3 says, the fan is to run continuously, have a break glass shut-off switch, and an exhaust vent located within 12 inches of the elevated floor. The exhaust air shall not be recirculated back into the room, In addition, it is important to know how the exhausted fumes mix with the outside air. NFPA also says the fume discharge shall terminate above the roof. Now, when a chemical storage building is installed inside a larger building, the fan must be installed on the roof or wall of the user's building. Negative pressure must be maintained all the way from the chemical storage building through the duct to the fan. If the threat of an explosion is high, and or to avoid installing explosion relief, it is permitted by meeting the requirements of NFPA 69, paragraph 3.3.3, quote, ventilation or air dilution, end quote. Paragraph 3-4.1 adds, quote, suitable instrumentation shall be provided to monitor the control of the concentration of combustible components, unquote. And 3-4.3, quote, alarms shall be provided, end quote. Now, what has been accepted is having dual or secondary fans operate as an emergency backup or redundant system. Fan number 1 would run continuously by adding gas sensors that monitor concentration for gas alarm and a sensor that monitors air pressure in the exhaust stack for the number 1 fan gets a fan malfunction alarm. The gas alarm will turn on the second fan to increase the air intake. The fan malfunction alarm would also turn on the second fan to maintain the air intake. When needed, an emergency standby generator would provide power for this dual fan system, or it would be connected to the main facility's emergency power grid. This dual fan system would never allow a flashpoint mix of fume and air to occur. So, even if someone was to light a match, an explosion would not take place. Now, here we have 4 photos. The one in the upper left-hand corner, there is a blue strobe on the roof edge for a fan malfunction alarm. The yellow strobe is for the sump spill alarm, and the red strobe for the fire alarm. There's also a single fan at the top of a single duct over a single exhaust vent. Then the photo on the right shows dual fans at the top of a dual duct over dual exhaust vents. In the lower left-hand corner, you've got an upper exhaust fan outside a vent opening. Inside the vent opening is an explosion-proof motorized louver. At a predetermined temperature setting, the louver will open and the fan turns on, pulling hot air off the ceiling. Supposedly a poor man's air conditioner. But in some cases, there are stored chemicals whose fumes are lighter than air, and a chemical temperature could trip their removal with this system. And in the last photo in the building on the right, you've got a couple of ducts that rise up from the exhaust vent opening up to the roof's edge and then over the roof's edge, and then the fan is mounted on top of the duct.